A pleasant day, math wizards. We are done with our lessons in each kind of quadrilaterals. And today, we will apply the properties of each into real-life problems. I know that most of us is having a hard time of solving math problems. That is why we will use a math breaker map to solve each problems. Remember that this map will serve as our guide in how to solve the problems. We can modify or include other steps to make a clear presentation in our solution. Let's begin. At the end of the lesson, the students will be able to A. Solve problems involving quadrilaterals for a math breaker map. B. Apply the properties of a quadrilateral in solving problems involving quadrilaterals. C. Make a clear solution in solving problems involving quadrilaterals through a math breaker map. Now, let us start solving problems involving parallelogram. Pantograph was a device which a parallelogram was applied. It was used as a primitive copy machine. The device makes an exact replica as the user traces over the figure. If the diagonal MN meet LQ at X, find LQ if LX is equal to 2x plus 1 and XQ is equal to 3x. Okay, let us solve the problem by using a math breaker map. As an initial step, we need to write the problem in the first box. The first step, we need to have our illustrations. So let's say this is our parallelogram based on the pantograph that was given. Let us name each of the vertices with MN, LQ. And we need to find, let us have first the diagonals, because we need to find the measure of LQ with a given quantity LX and QX. Okay, identify the relationship between the given. Okay, so LQ is equal to twice of XQ, or it could also be equal to twice of LX. And LX is equal to XQ. So for the next step, we have to write the working equation. So I am going to use LX is equal to XQ. So I will substitute the quantities. 2x plus 1 is equal to 3x. On the next step, let us solve for the unknown. So now, 2x plus 1 is equal to 3x by the addition property of equality. So I will have 2x plus minus 3, x is equal to negative 1. Solving, we will be having negative x is equal to negative 1. Dividing both sides by negative 1, I will lead to x is equal to positive 1. Let us solve first with LX. I will substitute 1 to our quantity 2x plus 1. So that will now become 2 plus 1, LX is equal to 3. Okay, now LQ is equal to 3, and to solve for LX is equal to 3, so LQ is equal to twice of LX. LQ is equal to 2 times 3. LQ is equal to 6. Therefore, our final answer is LQ is equal to 6 units. Let us solve problems involving rectangle. A kitchen has a dimension of 11 feet by 13 feet. Mrs. Adams is putting a border around the kitchen that costs $2 a yard. How much will she spend to put up the border? So again, let us use a math breaker map to solve the problem. As an initial step, we need to have the dimensions and the illustrations of our problem. So that is 11 by 13. And we need to put a border around the given kitchen. So that costs $2 per yard. So what relationship exists between the given? So in this case, we need to get the perimeter. And perimeter is the distance around the given polygon. So P is equal to twice of L, which is the length of the given rectangle, plus the width, write the working equation. We will also include, since we have the perimeter, P is equal to 2 times L plus the width. We also need to get the cost in dollars. That will be equal to cost is equal to the perimeter times $2 or times 2. Now, let us solve for the unknown. Let us first have the perimeter of the given rectangle. P is equal to 2 of length plus the width, which is 11 plus 13. Adding then, P is equal to 2 times 23. And P is equal to 46. Since it is in feet, we need to divide the given perimeter into 3 because a 3 feet is equal to 1 yard. Therefore, we need to convert it and divide 46 by 3. So, that is equal to 46 divided by 3 is equal to 15.33. Now, to get the cost is equal to 15.33 times 2. So, the answer now will be equal to 30.67. Therefore, our answer is $30.67 for the kitchen border. Songan, purchase an expandable hat rack that has 11 pegs in the figure. H is the midpoint of the diagonals KM and JL. If the shortest possible distance of the side KL is 5 and the diagonal is 30, what is the largest possible distance of LM? Let us solve the given problem by using a math breaker map. As an initial step, we need to have first our illustration. So based on the given, we will be using the rectangle. The expandable rack is in a form of a rectangle. The smallest possible width will be 5. So for KL, that is 5. And the diagonal is 13. So, the measure of the diagonal here is 13 units. And what is the largest possible distance of LM? And that is the length of the given quadrilateral or the given rectangle. Okay, so now, since it is a rectangle, identify the relationship between the given. So, based on the given, we can see that there is a right triangle exists. To get the value of x, we will be using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And a will be equal to 5, b will be equal to x, and c, which is equal to 13 as our longest side, and the side opposite the right angle. Okay, so what will be our working equation? I will now substitute. So we will be having 5 squared plus x squared is equal to 13 squared. Moving on, to solve for the unknown, let us have 5 squared plus x squared is equal to 13 squared. Okay, so isolating our variable x squared, so we will be having 13 squared minus 5 squared. Solving further, you will be having 169. X squared is equal to 169 minus 25. X squared is equal to 144. Solving for x, square root of 144 is 12, positive and negative 12. And since we are pertaining to quantities or measurement, we will be using the positive one. So x is equal to 12. Therefore, for our answer, the largest possible distance of LM is equal to 12 units. LM is equal to 12 units. The properties of a rhombus. The Navajo people are well known for their skill in weaving. The design at the right, known as the eye dazzler, became popular with the Navajo weavers in 1980s. If the measure of the two sides of one of the quadrilateral is 9x minus 77 and 3x plus 7, what must be the value of x to make it a rhombus? Let us use a math breaker map to solve the problem. So we need to verify or to make the given figure there is a rhombus. So let us verify by using the illustration first. So let's say this is our figure, and one of the sides is 9x minus 77 and 3x plus 7. Since this is a rhombus, let us identify a relationship between the given. So, one of the properties of a rhombus is a parallelogram with all the sides congruent. Therefore, we can say that all the sides are equal. So, if we name A, B, C, D as the name of the rhombus, we can say that AB is equal to BC. Moving on, let us write the unknown. Let us write the working equation. So we will now have 9x minus 77 is equal to 3x plus 7. So let us solve for the value of x so that we will be able to make sure that the given figure is a rhombus. So 9x minus 77 is equal to 3x plus 7. Solving for x, we will combine similar terms and use addition property of equality. So you will have 9x minus 3x is equal to 7 plus 77. Now this will become 6x is equal to 84, and we will need to divide both sides by 6. The answer is x is equal to 14. Therefore, the value of x that will make the given quantities a rhombus is x is equal to 14. Let us apply the properties of a square in solving the given problem. The Cruz family is remodeling their kitchen. Each side of the floor measures 10 feet. What must be the value of x to secure that the floor is a square? So let us refer to the given figure, and based on the given, we have 3x plus 16 as the quantity of the given angle, and the other half will be 4x plus 4. And so, let us use the math breaker map to solve the problem. Let us have the illustration of the floor plan of the Cruz family, and based on that, there is a square, and that is 10 feet, and one of the angles, it has the measure 3x plus 16, and the other one will be 4x plus 4. With that, since all the sides are congruent, we cannot say that it is already a square. And for us to give a support that the given the floor plan is really a square, we need to prove that the angle or all the angles of the given quadrilateral is a right angle. So therefore, let us name the given vertices with A, B, C, D, and measure of angle ABD plus measure of angle CBD is equal to 90 degrees. Okay, and so let us write the working equation and substitute the given quantities for angle ABD, which is 3x plus 16, and measure of CBD is 4x plus 4, and equal to 90 degrees. So now let us solve for the unknown. 3x plus 16 plus 4x plus 4 is equal to 90. So this will become, combining similar terms, that will become 7x plus 20 is equal to 90. Isolating 7x, you will get 7x is equal to 90 minus 20. 7x is equal to 90 minus 20, you will get 70. So dividing both sides by 7, x is equal to 10. Therefore, the value of x to secure that the given floor is a square is equal to 10. Now let us apply the properties of the trapezoid. A house owner would like to build an extension roof to cover the side of his house and make a space for laundry. He is planning to see to it that the top of the roof is parallel to its base, so for its stable form. Given the quantities of the angle measured, what must be the value of x to make the top and the base of the roof parallel? Let us use a math breaker map to solve the problem, and initially let us start by having our illustration. So let's say this is the extension of the roof that we are going to have for the house, and this one will be the angle will be 10x minus 23, and this angle is 5x minus 7. Let us name first the given vertices with A, B, C, D for us to have a clear view of our figure. So since it is a trapezoid, we need to see to it that AB is parallel to CD, and with that we need to say that the given consecutive angles of a trapezoid must be equal to 180, or they are supplementary. Therefore, measure of angle B plus measure of angle C must be equal to 180. Now, I am going to write the equation by substituting the quantities for angle A and angle B and angle C. Okay, so measure will be equal to 10x minus 23 plus 5x minus 7 is equal to 180. Let us solve for the unknown. That will be 10x minus 23 plus 5x minus 7 is equal to 180. Combining similar term, it will become 15x minus 30 is equal to 180. So isolating 15x, it will become 180 plus 30. So 15x is equal to 180 plus 30 is 210. Dividing both sides by 15, x will be equal to 14. So the value of x to make the top and the base of the roof of the given extension will be equal to 14. X is equal to 14. The Rizal monument was a solid shape called obelisk. Each faces was in a shape of an isosceles trapezoid. An IT student was troubleshooting his Android application that measures the dimensions of an object from a far distance. He was able to measure the base and the mid-segment of one of the faces of the monument with 6 feet and 4 feet respectively. Due to the limit of the application, he couldn't take the measure of the top of the monument. What is the expected measure of the top of the monument of the face of an obelisk if it is an isosceles trapezoid? Let us use a math breaker map again to solve the problem. And with that, one face of the given monument or obelisk is a trapezoid. Therefore, let us have an illustration. So let's say the base is 6 feet and the other one is 4 feet, and that pertains to the midline of the given or mid-segment of the given trapezoid. And we need to find the top base or the measure of the top base of the given figure. So this will be your x. We all know that the relationship of the mid-segment and the bases of a trapezoid is mid-segment is equal to base 1 plus base 2 all over 2. One of the bases, base 1, it's either the 6 feet or x, and base 2 is 6 feet. And the mid-segment is equal to 4. Let us substitute the given to have our working equation. So we have 4 as the mid-segment. B1 is x plus B2, which is 6, all over 2. Let us solve for the unknown. We'll now have 4 is equal to x plus 6 all over 2. Multiplying both sides by 2, it will become 8 is equal to x plus 6. In this side of the equation, 2 will be eliminated or divided out. So by addition property of equality, we can have x is equal to 8 minus 6. X is equal to 2. The top measurement of the given monument, 2 feet. And that is our final answer. Hillary is planning to make a 3-layered cake for her friend. In her point of view, she wants it to be a shape like an isosceles trapezoid. If he planned that the top of the cake and the base of the cake has a measure of 8 inches and 20 inches respectively, what must be the diameter of the baking pan that she will use to fit in her perspective shape? So since that he wants to have a 3-layered cake in a shape of an isosceles trapezoid, let us have an illustration for it. So let's say this is her perspective of measurement. So this will be our illustration. So the base has a measure of 20 inches and the top layer should have 8 inches. What must be the measure? Again, it is a mid-segment. So this will be our x. Okay, so now the relationship between the two is involving a mid-segment. So mid-segment is equal to base 1 plus base 2 all over 2. And base 1 is equal to 8, base 2 is equal to 20, and mid-segment is the one that is unknown. Now, let us write the working equation. So x will be equal to 8 plus 20 all over 2. Solving for x, we have x is equal to 8 plus 20 over 2. X is equal to 8 plus 20 is 28 divided by 2. So x is equal to 14. To have our final answer, we can say that the diagonal or the diameter of the baking pan that is needed is 14 inches. Let us use the properties of the kite to solve this problem. Emiro is reconstructing his broken kite and we're able to retrieve the 30 inches and 45 inches spar diagonal from the given kite. How much area of fabric is needed to create a kite with the provided measures of the spar? The spar here serves as the diagonal of the given. Let us use a math breaker map to solve the problem. Let us have first the illustration of the given kite. So let's say this is your kite and the diagonal has the measure 30 and this one is 45. So it means that this is 15 or the long diagonal is 45. So now we need to get how much area of fabric is needed to cover up and to have a kite. So we will be involving the area of the kite, and the formula in getting the area of the kite is equal to involving the distance or the diagonals is equal to d1 d2 over 2 or diagonal 1 times the diagonal 2 over 2. So based on the given, diagonal 1 is equal to 30 and diagonal 2 is equal to 45. Now let us have the working equation. I will just substitute a is equal to 30 as the diagonal 1, diagonal 2 is 45 divided by 2. So let us solve for the area. Area is equal to 30 times 45 divided by 2. Area is equal to there is a common factor between the numerator and the denominator, which is 30 and 2. So we can have 30 divided by 2 is 15 times 45. And the denominator will now become equal to 1. Multiplying 15 and 45, that is 675 square inches. So our final answer now will be the area of the fabric that needed to create a kite, 675 square inches.
That will be all for today's lesson. See you again on our next video lesson. Like, share, and comment your suggestions on the comment box below, and don't forget to subscribe. To get notified with our latest videos, just click the notification bell.